Okay, welcome. This is for students of math for business and finance and math applications. This is the Chapter 2 summary practice test, and I'm going to work through these problems. And if you have any questions, you can pause, rewind, and rewatch the video, or you can either telephone or click on Contact Us from your Penn Foster account and email us and ask us an instructor for help with you understanding the problems. But I don't really think you should have too much problem with this one. All right, but anyway, let's move forward here. Okay, first question. Let me get there. All right, summary practice test 1. Okay, identify the following type of fraction. Okay, this one here is a mixed fraction. Remember that proper fraction is like 1 over 4, okay, 1/4. That's proper because the numerator is smaller than the denominator and you don't have a whole number. And improper fraction would be like 5 over 4, okay? The reason why that's improper is because when you're talking about fractions, you're talking about part of a whole. And since your numerator is greater than your denominator, that means you have a whole number. When you divide 4 into 5, you get 1, okay? And the remainder is 1 over 4, right? So that you convert that back into a mixed fraction. So you have mixed, which is like this, 5 1/8, because you have a whole number, and then a proper fraction. This is a proper fraction, and this is an improper fraction. And if you have an improper fraction, you want to convert it into a mixed number. The other thing that you want to pay attention to is you also want to always reduce to the lowest terms. So in other words, like if this was 1 2/4 instead of 1 1/4, whenever you have a mixed fraction or even just a regular fraction, a proper fraction, you definitely want to reduce to the lowest terms where you can. So 2 and 2 would go once, 2 and 4 would go twice, so that would be like 1 1/2. Okay? But I know that was long-winded for just answering one simple little question, but that goes towards the next test question. So let's see. Okay, identify the following type of fraction. Okay, and again, from the previous one, this is going to be a proper fraction. Why? Because 2 over 7, we don't have a whole number, okay, and our numerator is less than our denominator. That's why it's a proper fraction. A fraction is a part of a whole. Okay, question number 3. Identify this type of fraction. Well, if you look at question number 1, so now you know that 20 over 19 is an improper fraction because the numerator is greater than the denominator. All right, what we need to do is we need to take and divide the denominator into the numerator, so 19 goes into 20 one time, and there's 1 left over, so I end up with a fraction of 1/19. So that's a mixed number, and we need to convert the impropers into its proper form, and if necessary, reduce to the lowest terms. Okay, summary practice test 4. Question number 4, convert the following to a mixed number. All right, 163 over 9. Again, when you're talking about fractions, the over, this divisor, represents division. Okay, so we take the 163 and we divide it by 9. So 9 into 16 goes one time, and we're left with 73. 7, and we bring down our 3. 9 into 73 goes 8 times. 9 times 8 is 72. And we're left with 1 remaining. So our answer is 18 and 1/9. So we end up with our whole number here. Our denominator is the 9 that we're dividing by, and our remainder goes into the numerator. So we end up with 18 and 1/9. Okay. convert the following to an improper fraction. Okay, so we have 8 1/8. And while it's important to work in proper fractions, we definitely do want to convert into improper fractions in order to be able to do math. If I had an example, let's say I had 8 and an 1/8, and I wanted to subtract, let's say, or multiply or whatever, let's subtract 3/4. Okay, I can't work with this mixed number. I have to convert it into a fraction, and since it has a whole number and I have a fraction behind it, remember you're thinking in terms of 1, 2, 3, 4, 5, 6, 7, 8, and then 1/4 of this 9th one. Okay, we have to convert the mixed number into an improper fraction in order to be able to work with the mathematical operators of, addition, subtraction, multiplication, and division. So in order to do this, we take we multiply our denominator times our numerator, so 8 times 8 is 64. Okay, and the reason why we do that is because, remember, this circle represents one whole number, and when I chop it up into eighths, okay, any number over itself, so I'm dealing with a denominator of 8, so any number over itself is equal to 1, and that means I have 8 parts in 1. And if I have 8 whole numbers, okay, so this one has 8 parts, this one has 8 parts, this one has 8 parts, 8 parts, 8, 8, 8, and 8. If we add these all up, we'll find out that we end up with 64. Okay, so we're, and that's the reason behind multiplication and division, because it makes addition and subtraction a little bit easier. So I take 8 times 8 and I get 64, but I have this remaining 1/8 over here, so I add the 1 and I get 65 over 8. Okay, that's the conversion from 8 1/8 into 65 and 65 eighths. Okay, I hope you understood that. If not, definitely, excuse me, definitely telephone an instructor. Okay, number 6. Calculate the greatest common divisor of the following by the step approach and reduce to the lowest terms. Okay, so we have 63 over 90. Okay, and I want to know what the greatest common divisor is going to be using the step approach. So let's work through that. Okay, so I take my 90 and I divide by 63. Well, 63 can go into 90 one time. That gives me 63. Subtract 7, so I have 27. Okay, so now 27 becomes my divisor, and I'm going to divide that into the 63. 27 into 63 goes 2 times, so that's 54. And that leaves me with a remainder of 9. So I take the 9 and divide that into 27. 9 and 27 goes 3 times. So my greatest common divisor is going to be the 9. Right? So I'm going to divide 63 by 9, divide the 90 by 9, and that's going 9 into 63 goes 7 times, and 9 into 90 goes 10 times, and that's my answer. So my greatest common divisor is a 9, and when I reduce to the lowest terms, I end up with 7/10. Now, this was using the step approach, and notice what happens with the step approach. I started out with dividing the 63 into the 90, okay, and I ended up with 27. Well, that 27 becomes my new divisor, and my previous divisor is now what we're going to be divided into. Okay, and then when I have a remainder here, that becomes my new, and my 27 from the previous one, now that's what gets divided into. Okay, so that's kind of like the process to end up when you get to 0. In other words, 9 times 3 is 27, and we end up with 0. Whatever your divisor was the last time, that's what is your greatest common divisor. Okay, and according to this problem, we're going to divide, by the 9/9, or divide your numerator by 9 and your denominator by 9. And that's using the step approach. Now, me personally, what I would have done is I would have said, okay, I've got 63 and 90, okay, and again, it's a matter of multiplication, understanding and knowing what your multiplication is, okay. If I'm at 63 and, that's 7 to 90, I'm sorry, that's 7 away from 70. In other words, if I had 70, I know that 9 is 63, all right? 9 times what? Gives me 63, right? 9 times 7 is 63. So I know that that is one of my, I have 9 there, and I know I could divide 9 into 90, which gives me 10. So immediately, I didn't spend all that time doing the step approach, okay? Just because I know my times table so well, I know that 9 times 7 gives me 63, and I know that 9 can go into 90 just because I have a 9 there. 9 into 90 tells me 10 times, okay? And so I know I'm talking about 9 as my greatest common divisor. And then I do the math. 9 into 63 goes 7, 9 into 90 goes 10 times, so I end up with 7/10. A lot faster and quicker without having to do all of this division, only because I know my times tables. So if you need to use the step approach, use the step approach, but I would have a tendency to try to become more, think and use what you know, okay? Because you're going to have to think when you're doing all of this division anyway, right? It's, 2 different methods. Take it for what it is. I explained how I would do it. Okay, so in the next video, I'll move on to question number 7.